Hi everybody, I just wanted to take a short moment to talk about the flowers with petals of 5 or pentagon shaped designs. When we look at a pentagon, I have other videos describing how we have the golden ratio, or the phi. It's the number 1.618, and it is going to give you the Fibonacci spiral. The way we get 1.618 is to divide the Fibonacci number by the previous number, and the larger the Fibonacci number will get 1.618, or close to it. It's a never-ending decimal. So that same number responsible for spirals is found in many other shapes, even though you don't see a spiral. That same balance and proportion is in there. One place we see it is in the pentagon. If you were to take this red line and divide it by this green line, you're going to get that same golden ratio, 1.618. In fact, when you divide this green line, or actually this red line here, pink, divided by the second green line, then you also get that same proportion. So one of the ways I've begun to look at flowers in general are just stars. If we take this and connect the flower petals, you have a symmetrical or repeating pattern that can be rotated 5 times and it'll look the same. So we see stars with 6s and 5s and many different flowers, as well as just the spiral itself, like a rose or a sunflower. Let's take a quick look at some of the flowers I've seen on some of the walks I go on. These are all flowers of 5, and they have 5-sided stars with the Fibonacci spiral number, or the golden ratio, phi, built into the actual shape. This, I believe, is like an apricot or a peach blossom. I believe I've seen them in orange blossoms, possibly strawberry blossoms. I forget if that's 5 or 6. Here's a plumeria. They have 5. Here is type of, not a type of lily. Here's a flower I saw today, and when you look at it, it has the pattern of 5 built into it. Here's a closer look at the insides. This might be a strawberry blossom, both 5 petals, and then when we zoom in, we see the same 5 sides repeated in the seeds, or in the place where the pollen is. Here are a couple more flowers. And so this one has 5 petals, and where the petals have a yellow color at the very tips also makes a 5-sided pattern. Sometimes even the little flowers here will have 5 as well. And so when I look at these, I tend to look at a star. So it looks like there's this little teeny piece here has 6-sided star, but the flower itself has 5-sided star. Here's some more. And again, even the insides where the pollen is have 5 sides. So it's a very common thing in nature. A lot of the flowers that we see around the neighborhood, even this flower I believe had 3 petals, but the inside of it had a 5-sided star, little teeny flower on the inside. Here is, I believe it's either a zucchini or a cucumber blossom, has 5 sides. And this has 5 petals, and then as a result, the inside here takes the shape of a 5-sided star. This has 5 petals, and in the inside it will repeat that 5-sided shape. Here is a dragon fruit, and even though there are many petals and little blue things, the center of it has 5-sided star. And so again and again we see that repeated pattern. This is a plumeria that's still opening. So time and time again, this is the Rose of Sharon, and the main petals have 5. We see that beautiful pattern. Here's a star fruit. Here's inside of some little flowers that are shaped like a bulb. And it just gives us something to appreciate, that the golden ratio, or the number 5, the same number that's responsible for the Fibonacci spiral, which you can watch and learn more about in another video. The math is in these shapes, the proportion. This is a hibiscus, and not only does it have 5 petals, but then it has this little star-shaped thing in the middle with 5 as well. So 5 is very common, as well as 6s. I'll do another video showing some of the flowers with 6. But 5-sided flowers, even though you don't see a spiral, contain the mathematics of the golden ratio inside of them. Maybe that's one of the reasons we love pentagons and 5-sided stars so much. It's something that is all over the place, and maybe it's in our subconscious because we've seen it our entire lives.